Okay, hi everyone. Welcome to today's session. Before we start, I'd like to know where you're come joining in from. So if you could drop in the chat, tell us where you're joining in from. I'd like to, yeah, to at least know before we get started. You guys, I don't know, can you guys use the chat? Just tell me where you're joining in from. That'll be really nice. Seems like no one wants to say hi. Fine. I'll try for the last time if I give up. Tell me where you're joining in from. Put it in the chat, whatever country, wherever you're joining in from. If you're joining from Mars, if you're joining from the moon. Yeah, just put it in chat. Let me know where you're joining from. Let's see if someone reply me. Okay, that was a failed attempt. Okay, someone did reply me. Okay, nice. Um, Hi Helena. Okay, hi, nice. Joining from Ethiopia. Nice. That's nice to know. I hope you guys have also gotten your emails about the project. So if you've not, please do find out about it. Yeah, people could join from the moon, by the way. So like the breakdown of like the projects you're meant to work on, it's all there. So I think it's due by Sunday, if I'm not mistaken. So you're all meant to work on it individually, but like you can work in teams to help yourselves, but like you're all going to submit individually. Team is just for you to like, rub off each other's strong points. Um, Once again, I'd like to say the bootcamp is still open to individuals that want to join. Like I need to restate that. So yeah, that's that. So I'm sure I'll speak out soon joining. So yeah, just let's chill, I guess. Okay, hi James from Kenya. Nice to have you here. So we have people from Ethiopia, Kenya. Um, and that's nice to know. I really hope the numbers don't suffer from the change in schedule. Um, 'Cause we sent out multiple mails. I think we sent out like 5 emails to try and remind people about today's session. And again, I must apologize once again. The speaker mentioned that Tuesday can't work for him, and that there are two options. Either we didn't have this session and we didn't have it at all, or we had it on a Monday, which is today. So we had to like say, okay, it's better if you come on a Monday. Our speaker is here. Hi, Marco.
Hey,
Nice to have you. Nice to have you. Thank
yeah,
you
thank you
so
for
much for.
organizing.
No, you're the one that's joining. It's nice to have you. I was just going to maybe give people like maybe like 4 or 5 minutes for them to join in.
Yeah, yeah,
Um, so like more like a free space for us. The people that are here now, I'm going to have maybe like inside info.
yeah,
Um,
agree.
yeah. Um, so yeah, I'm joining in from Enugu, Nigeria. Where are you joining in from?
So I'm joining from Italy, but actually
Lovely.
I'm Yeah, I live close to Venice.
Okay.
Um, but actually I'm based in Amsterdam. So we have I work
Okay.
for LangChain, and we have the office
Yeah. I know.
in Amsterdam, and I work closely with Mateus that last time did um
Yes. Yes. Yes.
the
Yes.
call.
Yes. Yes.
Yeah. Uh,
Lovely.
yeah.
Langchain basically allows you to work remotely, or do you have
Uh,
to be as a hybrid?
Yes. So at the beginning, it's really good to work remotely, also because like you know, we're not like a huge company. Like we are around
Mhm.
100 people, employees, and
In the entire company?
yeah. But we are growing really fast. Like when I joined,
Mm.
I was number 50, and now we are already after 5 months, we already doubled the number. So we're growing really fast, and at the beginning,
Yeah.
it's good to work remotely so that you can work either with the European team in the European time zone, and also with the
Yeah.
US time zone. So it's really nice.
Mm.
Of course, it's really good to have a physical office to go there and work closely with other, such as like Mateus. And
Hmm.
right now in Amsterdam, we are around 4 people, and
Okay.
we opened the office in May, and half mid May, and now we organizing events, and yeah, it's pretty exciting. What
Yeah,
about
I
what?
can see you having.
Yeah. What about you?
Okay. So I am the founder of NSKDL AI.
Mhm.
We're a non-profit AI community. So I'm going to tell you about how we started. So like when I was an undergraduate in school, my friends wanted to get into AI, and so I was like, okay, like why don't we try and solve this problem? So we started a small community here in university, and so we'd always like reach out to people to give us talks. Reach out to people from Google, IBM, Stanford. So we kept on doing that, and the community kept on increasing. We started off as 9, then we got to 30, and we got to like 100. And so we just got registered as a non-profit about maybe a month ago. Um, and so we now decided that why don't we try and organize a bootcamp, because not just for our community members, but for people, many people like so in the era of AI agents, and we always try and help not just people, but organizations too. But we're just at the beginning stages of with organizations. Primarily, all our work has been done with individuals trying to help them leverage AI and all that. And so the bootcamp was meant to be made for like our community, and it blew up. So we're collaborating with multiple people from different parts of the world, and then just blowing up from 100 to 200 to now 1,300. It was not planned. It was not planned. Even reaching out to Langchain, I remember the lead. I remember I just told him I want to talk to Langchain. So I sent the mail, and I was scared. I was like, this guy's probably not replying me. When I saw Matthias replying, I was like, whoa. So I think the community lead actually mentioned that he knows you. You guys spoke before. I'm sure if he joins the call, he'll probably like say hi. Ibuka, I don't know if you know. Chiko Ibuka. He said you guys spoke before you even got into Langchain. I don't know if you remember.
Yeah. Sorry.
So did you hear everything I said?
Sorry. Can you repeat? Maybe my internet connection is not the best. Um,
No, 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 but did you hear everything I said before now?
yeah, yeah. I heard. Yeah.
Okay. So I said the lead of the community, Ibuka, he mentioned that he spoke to you before you joined Langchain, so he knows you. I don't know if you know him. Chiko Ibuka.
Ah,
He said you
okay.
guys spoke on LinkedIn. So probably when he comes on the call, he'll probably like say hi. Maybe you remember him.
Yeah. Yeah, absolutely. I mean, we already open. I mean, we started as an open source company, and we are still an open source company. So we're really open to the community to collaborate with anyone, and of course, like with the AI, with these AI times, the pace is really fast. Like there are new
Mhm,
models, there are new concepts coming
mhm,
out. every week.
Yeah.
So of course, it's good to have these sort of community calls where you show the new things that are going, what's going on in the AI field, and of course, if someone's like reach out, we don't put it in spam, but we try to understand, um, try to help if we can, and if they have ideas, of course, they are very well welcome. So,
Thank
and
you.
also it's
Yeah,
great.
that's
Yeah, it's crazy that you said that you managed to create this community. There's a lot of people joining, and I'm really happy to talk here and show, yeah, a little bit of the features of our products, of our open source, and yeah, of course.
thank you, thank you so much. I think we have a good number. So are you going to be presenting or are you going to be doing a demo? I don't know. How do you want your class to
Um, so I think I could just present a few slides,
go? Okay.
uh, just to explain what are evaluations, what is LangGraph, our orchestration
Mhm.
framework, and I know that this session specifically is about observability and evaluation.
Yeah.
Um, so what I would do is just explain a few slides and then go into the actual platform to show what you can do.
Okay. Okay. Solid. Okay. So for people who are just joining, we're having Marco Perini on our speaking to us today. He's a deployed engineer at LangChain. And he's going to be our tutor for today. I hope you guys learn a lot. If you have any questions, please put it in the Q&A section. We'll answer all the questions at the end of the session. I'm probably going to disable the chat. And please do not try and write on the screen because I know people do that a lot. So please don't do that. If you do that, I'm probably going to ask you to make you kick you out of the call. So please don't do that. So Marco, it's all yours right now. I hope I pronounce your name well. Marco Perini.
Yeah, Marco Perini. Yes.
Okay, thank you very much.
Marco Perini is
Okay,
perfect.
okay. So yeah, it's all yours now.
Okay. And of course, if you have questions during the demo, just maybe post it in the chat. And if you want to do it as a VM moderator, so you can like read the questions, I'm happy to answer all of those as well.
Okay, okay, okay.
Okay, so let me share my screen. Mhm. Mhm. Okay, so slideshow this. Okay, um, so a little bit of introduction. I'm Marco Perini. I'm a deployed engineer based in Amsterdam, and today I'll just go through some slides to just explain how to build agents, how to monitor them, how to evaluate them, and on a conceptual level, and then I will just hop on Langsmith, which is our platform for monitoring, evaluating, and prompt engineering all these agents in these LLM applications. So let me start with the presentation. We are I think we are all familiar with the concept of LLMs, so we can think as LLMs as a black box where you put some inputs as string, and it will do something under the hood, and then it will generate another some other strings, which is an output. So if we give as input high, we can uh, we will likely receive an hello or how you doing. Um, and a really famous architecture that we see nowadays that it's been around for a year or so. It's called the React agents. So React or reasoning and act are basically is basically an architecture with an LLM that calls some tools in a loop. Many LLMs support tool calling, so you can provide a bunch of functions, and based on the input of the LLM, the LLM can decide whether to call this function with the appropriate arguments, and also provide a response, which will contain the name of the tool that the LLM wants to call and also the argument. So for example, this city, Boston. And it's very, really simple. So this LLM can take as input as a query and can, given some function, can give as output this payload for the tools. If you put this in a loop, we have where we mentioned the React agent, and this is a really simple, the most simple architecture for creating chatbots, because um, you can have a user input, the LLM will reason about that input, will call a few functions, and then will take the content retrieved for those tools and generate an output. And then it will route to an end. Next time you will invoke the LLM. If it has all the context from the chat, you will be able to ask follow-up questions. This is really nice, and it works. But what about put it into production? Will it really be able to handle all the usage, all the incoming requests, or what about the complexity of the user query? Maybe um, um, you don't have the right tool to answer that query, and so the LLM will provide a wrong answer. And so these are really genuine questions that you will ask yourself. So will it be able to scale? Why is the agent hallucinating? How are my customers using the app? And or how do I improve the response of my agent based on customer feedbacks as well? So let's start with the agent orchestration. So how do we actually build these LLMs that are called one after the other? So this is what we just mentioned. So one thing that you could do with this React architecture is adding multiple tools, so more tools. But of course, if you add many tools, then the LLM will have the difficulties in understanding which tool to call. We may have multiple tools, multiple similar tools, and it might get lost in a long conversation history. So if you don't manage the whole conversation history of your chatbot, then the LLM will not be able to route to the right tool, and so on. So we need a way to actually use the flexibility, have the flexibility of these React agents, and also another framework, another way to make it a little bit more deterministic. This is a chart that shows based on the number of tools that we provide and the number of tokens, the pass rate of different models based on some customer support tasks. We can see that by increasing the number of tools and the number of tokens, the pass rate decreases. So how do we actually combine a chain with predetermined flow where you call an LLM whenever it's needed, and how do we actually use this React agent architecture, which is flexible but a little bit less reliable? And that's why in LangChain we have developed LangGraph, which is our open source orchestration framework for that merges both the concepts. In LangSmart, you can have full controllability, so you can either use this React architecture or you can create custom workflows. It supports streaming, so if you ever seen a chatbot like ChatGPT, and you see that the response from the UI is not provided all at once, but it is streamed and built up while it is generating. That's a way to show the response to the user without having to wait a long time. It supports persistence, so we support short-term memory, so the ability to actually um, have context of the previous conversation. So you can ask follow-up questions, long-term memory, so for storing user preferences, and also human in the loop. We support human in the loop, which is a really powerful features that allows you to interrupt the execution of this agent of this graph at a certain point, and then wait for a human input. And then once the input is received, it will be re-executed exactly from that point. So it doesn't need to be re-executed from the beginning. Um, Landgraph is you can think you can think of it as only the orchestration, and you can create it with you can create multiple nodes connected to each other with some edges, and you create a graph, and each node can contain any arbitrary Python or TypeScript logic. So you can use both, and you don't necessarily need to use the LangChain ecosystem. And as you mentioned, we could create a more custom workflow. So for example, in this case is a simple RAG retrieval workflow, so like a RAG pipeline, where we retrieve the documents which are stored maybe somewhere like in a vector database. We grade those documents and we add a conditional edge, whether if it's relevant, then we generate the answer. Then what we can do, we can add a customer agent. So this is basically a React architecture with a human in the loop in the middle to verify the identity of the user. So there's this LLM, which is in the assistant node, which has these tools available. And this is nice. We have a custom workflow, and we also have a predetermined React agent workflow. How can we combine them together? We could do so adding a supervisor node or supervisor agent, and this will create the so-called multi-agent architecture. And then we can add more functionalities like long-term memory, for example, for storing customer preferences. And this is really conceptual, but you can create everything in LangGraph open source. So you just have to install LangGraph, and you can either, like in the left, create custom workflows. For example, for attribute documents, grade them, and generate a response. You can create React agents. We provide a few pre-built modules for it. So in this case, we have a method called create React agents, where you specify the LLM model that you want to use, the list of tools available, and some system prompts. And this basically will take the user query, reason, and then call a few tools for then generating and providing a response. And also if you want to combine all of this together, we have the LangGraph Supervisor library, open source library, that allows you to provide a list of agents. So for example, the RAG pipeline and the customer subagent, and then combine them all together. And this will handle the handoffs to the subagents. So the supervisor will decide where to route and when to call a specific subagent, and will handle also the conversation history. We do provide we do have a open source LangGraph command line tool, which allows you to create a spin up a really LangGraph server. that allows you to visualize and interact with the agent dynamically from this and visually from this interface. So from here you can actually see the actual flow. Okay. Um, yeah, this is a fun slide. There are some people saying that why do I need an agent framework? Why don't I just use a for loop, LLM in a for loop, or create everything from scratch? Of course, you can do that. But nowadays, it's really mandatory to have a certain feature out of the box, including the modularity. So you want to be able to recreate or create simple agents and then reuse them and in bigger workflows or over time. You want to have persistence out of the box. So you want to have conversational threads, error handling, fallbacks if the LLM calls fails. You want to have short-term and long-term memory, human in the loop, the capability to fork the execution of an agent. Maybe you want to try different prompts and visualize the behavior. And and also, of course, it saves time having a framework, and it allows you to add authentication authorization as well. And the last month we had 6 million monthly downloads only on LangGraph, and a lot of people are contributing to it and using it. And actually, I came in contact with people at LangChain because I contributed to LangChain GitHub repos and projects. So um, I would suggest if you start coding like in Python, TypeScript, or AI agents, generative AI, to contribute, try to pick a open source project and try to contribute to it, and it will be really helpful, and good things will happen eventually. Um, okay, so this is the orchestration part. Then once you have created these agents, how do I actually monitor them? How do I make so that for every change that I make to my agent, the quality the quality of the response of my agent is still good. Uh, and for that we need to have a tool that allows you to monitor these agents real time, and also try different version of your application, and provide a score that you can compare. And then we pass to the agent evaluation section. Are there any questions so far?
Um, no, nothing Q&A,
Mhm.
none for now.
Okay. So then I will continue with the slides and then jump into Langsmith. Um, okay, awesome. So we have seen how you can create agents with LangGraph open source, and let's see how to evaluate these agents. So the first thing that you will do is build a first version of your application and give an input and visualize the output. You can do this maybe a few more times, and with different inputs, and see whether the output changes or it's good enough. And this is called a vibe checking. It might be good for a few trial, or if you if you want to test it quickly. But this, of course, doesn't scale in a production environment and where you want other people to use your agent or your application over time. And so we need more concrete testing. So we may have we might have different version of our application. We can try different prompts, different instruction for our models. We can try different models or even different agent architecture. And so we want to define and measure the behavior, the quality of these applications, different version through evaluators. There are different types of evaluations. There are online evaluation and offline evaluations. Online evaluation are basically good for evaluate the production data that is coming from your production deployment. While offline evaluation, and they don't require a ground truth, so they mainly relies on the instruction that you give to the LLM. While offline evaluations are really good for starting and to have more complex evaluations and understanding how each step, how each um, phase on your of each node of your graph is behaving. And and these require a data set to test your application against. So let's start with online evaluation. Okay. So actually, let's start with offline, which is a little bit easier to understand. So offline evaluation, we can start. What is an evaluator and what actually evaluates? So we can start with one example. An example can contain an input that we and a reference output that we expect our agent to generate, and then we take these inputs and we actually invoke our version v1 of our application against that input, and we generate an output. And basically to generate a score. So for example, is this output similar to the reference output, or is it good enough? To understand this, we need to have create evaluators. So they take input, they take a reference output, and also an output from your real application. And an evaluator outputs a metrics. So once you have this metric, you have one example, you may want to create a dataset representative of the most common use cases of your application. So if you have a chatbot with different use cases, then it might be good to have build an initial dataset. It doesn't need to be like huge, but at least 10, 15 samples. And and there are a few ways to create this data set, either manually. You can manually create a data set. You can generate the example in synthetic way. So for example, an LLM can generate synthetic data, or you can build this data set out of traces from production. So now you can define a few evaluators, and this will be the main flow for running this testing different version of your application. So you have one data set, you have different version of your application, and then you have a few evaluators for in this case assessing the accuracy of the response and the hallucination. And here you can, for example, understand which one performs better. There are two main types of evaluators. There are custom code evaluators. So there are basically Python code or TypeScript code, and they take as input the inputs, reference outputs, and the output from your application. And you can use Python code, for example, to compare the output together. The other one of the most common evaluators is LLMS Judge, which basically use another LLM to judge to provide a feedback score given the inputs, reference outputs, and outputs. And of course, you might ask yourself, okay, but who validates the validators? Who's gonna validate the LLM feedback score? Um, there is this good papers from guys at Berkeley that basically they basically suggest a way an architecture where um, uh, humans annotator evaluate the response of the LLM as a judge itself. Um, and so it makes you think that we still need some human in the loop to actually create high quality LLM applications. Um, so this is the main flow. So we have the application, we create a data set, we give the inputs from the data set into the application, we generate an output, and we take it, we invoke these evaluators, which are basically this function that takes inputs, outputs, and reference outputs. And then the results of these evaluations are called experiments. So what you can do is compare the result of all these experiments and decide which version of the application performs better for your use case. Analyzing experiment results without testing, it's pretty linear, and also with testing evaluation, it's this new diagram where you have different version of your application, you test it against a data set, and you have a few evaluators as output. So let me go back. Now we have talked about offline evaluators. And in LangChain, we have the concept of online evaluations as well. So we monitor production data to see, for example, to understand the user behavior. So we take data from real user, they test it against our application. We need a place where to put all this data, which is the production user's data, and then we run evaluators, which could be, for example, accuracy score, hallucination, and helpfulness, and so on. So the main difference with offline evaluations is that we do not need a reference output. So we only have the input and the output from our application. And then the metrics, the feedback that has been generated, it will be attached to the run itself as a feedback. And this is helpful if you want to create, for example, these charts that shows um, um, the feedback score over time. So, for example, if you have a chatbot that answer questions related to our documentation, we can see the score over time and understand the how your user are actually using your applications. Okay. Okay, you can set up agentic evaluations at different steps of your agentic workflow. Can be end to end. So, for example, you can have a data set that contains the input of your application and the answer, and then evaluate that part. It can be at a specific step. So, for example, in this case, we want to evaluate the retrieved documents. Um, so end to end, single steps. So we can evaluate this great documents node and see whether the LLM which is called inside this node is providing a good grading system. You can evaluate trajectories as well. So trajectories are all the steps the sequential steps that the agent takes to generate the answer. And the most common trajectory is whenever an LLM calls a tool. You may want to have a data set where you expect, given that specific input, you expect the agent, the LLM, to call specific tools. And this is, or a sequence of tools. And this is the trajectory. So for example, if you take a React agent as an examples with this LLM and with these tools for get calendar and schedule meeting tools, these are different types of trajectories. So we can have ordered expected trajectory. So if the expected trajectory, if the V1 trajectory has the elements unordered, then it's different than this one. Can be unordered, so this one is equal to this one, even though the time is swapped. And they can also be subset or superset of trajectories. And also agents, if you have a chatbot, needs to be evaluated at different levels of granularity, such as also for multi-tone conversation. So not just one input and one output, but evaluating the multi-tone conversation that the user is having with the agent itself. To create these evaluators, we have a few open source library. So we have OpenEvals that provide some LLMs judge evaluators out of the box. And we do have agent evals as well for creating trajectory LLMs judge. And whenever you want to put, you can do this locally. But whenever you put all of this in production, you want to have a automatic way for running tests whenever there's a change in the code base, and that's where using OpenEvals or agent evals together with PyTest, for example, which is a testing library, is really important. But of course, you may want at the beginning you built your agent and you don't know what do I do? Do I deploy this straight to production or do I add observability layer and evaluations? In May we had a interrupt event, our first big conference in San Francisco, and our CEO Harrison stated that great evaluation starts with great observability, and that's why we have a product. We have this platform that allows you to actually visualize all the traces and all what's happening under the hood of your agent, which is called Longsmith. So in this case, where do I put all this data into Longsmith that allows you to visualize the different steps, the LLM calls, the documents retrieved from the vector store, and so on. So Longsmith provides many more features for collaboration, observability. You have alerting, evaluation, of course, for measuring performance and using human feedback, and also prompt engineering. So you don't need to manually test each prompt, but you can or push a new version of your application with a new prompt, but you can do this directly from the UI. And this is pretty helpful and a fast way to iterate your application. And so we have monitoring. I will just go fast here because I'm gonna show it to you later on. But we have this monitoring phase with the tracing view where you see all the different steps. You have this monitoring and alerting. So whenever there's the quality of your application, of the output of your agent is degrading, then you can trigger a webhook or send a notification to Slack, for example, or via email. Um, you can, of course, test and evaluate your application and visualize the different scores and compare, do A/B tests with prompts and architecture and models and so on. And this is the prompt management where there's the playground. You can try different models and different prompt itself and visualize the output side by side. And Longsmith can be installed as an SDK with the pip install Longsmith SDK. We do have also a TypeScript SDK, and it works out of the box with LangChain ecosystem. So if you have built an agent with LangGraph, for example, or with vanilla LangChain, it works out of the box. Otherwise, it's pretty straightforward still to use it in a non-LangChain ecosystem application. So you just have to add a traceable, a decorator to your function in Python, and there are also other ways to do this. And so with LangGraph and Langsmith, we try to tackle most of the life cycle, the development life cycle steps, phases, from the agent development, testing, evaluation, deployment, monitor and detect, configuration at scale, and memory and feedback. So after this one, I have a few more slides, but I just want to go into hop on Langsmith and show all the different features that we have, if that's okay, and if there are no questions.
Yeah, Marco. Yeah, take your time. Take your time, please. Like, there's a question.
Yeah.
So Mike asked, the agent gets the final answer, but uses unnecessary tools and repeats steps. Is it a success or failure? Why? Regarding the principle.
Um, can you actually repeat, because I think so. Let me.
It's in the chat, so
Yeah,
you
okay.
could also read it.
Yeah, sorry. Um, Okay, so the agent gets the right final answer by using unnecessary tools and repeat steps. Is it a success or failure? Why? Regarding the principle. So I think it really depends on what you want to achieve with your agent. So if you want your agent to be fast and provide a response as soon as possible, then you may want to evaluate or to tweak your agent to be able to at first be able to code the right tool straight away. But maybe the accuracy, I don't know, maybe it needs to call multiple tools to actually generate the answer. And so it doesn't have enough context for generating the right answer, and it can be partial. Otherwise, there might be cases where you want the agent to gather more context. So even though it doesn't use the right tools right away, but it calls multiple ones, you need to understand why it calls those tools. Was it because it needed more context to actually provide a good answer? Or was it because the prompt was not tuned enough for the LLM to actually grab the right tool? Or is it because you have different tools which are similar to each other, like they have similar um, instruction or similar inputs and so on. So it really depends on what you want to achieve. If it's repeats, if you think using unnecessary tools and repeat steps, then it might be a good idea to try different models. So if you're using, for example, GPT-4 or Mini, and it doesn't work and it calls like different tools, then you may want to try a more powerful model, like for example GPT-4o. Do you have are you tackling some code, agentic code tasks then you may want to use Claude, for example. Um, or you could either try different prompts and maybe provide some examples in the instruction as instruction. So the so-called few shot prompting. So you basically take a few examples on the expected output, and then you put them into the context of the LLM. Um, and also, or you may want to try different architecture of the agent itself. Yeah. Okay.
Yeah, so that's all I think we can move.
Thank you, Mike, for the question. Um, okay. So let me okay. So let me share my screen. So 1 second. Okay. So hopefully I hopefully you understand now how to what you can use for creating agents or React applications, AI agents, and what an online offline evaluation is. Um, so before going into Langsmith, I wanted to show you this, which is our chatbot, which is public. You can use it, which is called Chat Langchain. And Chat Langchain basically answer questions related to our documentation. So Langchain, Langgraph, Langsmith, Langgraph platform. And under the hood, there is an agentic system where we retrieve documents from a vector store and provide, given the context retrieve, we generate an answer from the user. So let's click on how can I run a model locally on my laptop with the Llama. So basically, we will invoke our agents, and under the hood, will generate a research plan. It will show some sources. So, for example, all different pages in the documentation where it thinks the information for answering that query is stored. And we see the selected content and the answer generated. So this is nicely formatted into Markdown. And this already nice because you can see the inputs, you can see the research plan with the selected context and the answer itself. But if you're building a chatbot, you also want to understand how can I improve this system? How can I make it faster, for example? And that's where Langsmith comes into play. So let's go to Langsmith. This is the main interface. We have a tracing project called Chat Langchain v3. And we can see here that our query has been already logged into Langsmith. And here we don't only see the inputs and outputs, but we see all the different steps that happen under the hood to generate that query. We can see all the different LLM calls. For example, and here we have the system prompt, we have the human prompt, the output, and so on. So the list of tools available. In this case, we have a tool called Plan, and which is being called. Also, if there is this retrieve document nodes with the vector store retriever, and you'll be able to see the different documents that have been retrieved at these specific steps, and you can just click in and see whether this chunk is helpful or not for answering that query. And if we scroll down, we see that there's the last LLM call. So we call a LLM model from OpenAI that has this system prompt with all the context retrieved till this point, and our user query, and then the output generated. And this is pretty nice for example, isolating issues. If you see that you don't really like the output or there is some errors, you can easily click in different steps here and see what happened and try to isolate the issue. You can also, if you want to improve your system latency wise, we have a waterfall view that allows you to see the different steps. So for example, in this case, contact research nodes have been called one after the other. So sequentially, one thing that we could do to improve the latency of these agents will be to invoke all these nodes concurrently or at the same time. And this is pretty powerful and allows you to iterate quickly and visualize what's happening in your application. You can also click in the LLM models, visualize the visualize the tokens used, so and the cost as well with the latency. Good. So now let's say that we want to, okay, let's say that we have an issue. We don't really like the output of our chatbot, and we want to have a way to actually iterate on the prompt and see if we can make it more similar to our likings. So what we can do is just click on Playground, and all the prompts that we see will be prompt over this Playground interface. From here, you can visualize the prompt. You can specify which LLM models you want to use. So for example, in this case, we are using GPT-4.1 Mini, but we can also use different providers, such as now we're using OpenAI, but we could use Anthropic, we could use Azure or others, Mistral, or also if you have a model, a custom model that is hosted by you, but it is compatible with OpenAI API specification. Maybe you are using Light LLM. And then you can also specify that as well and use that. And so let's say that I want to actually, since I'm Italian, I want the agent to respond in Italian. So let's just say you can only speak Italian. And we can press on start, and we'll be able to see real time the output of the LLM given all the context retrieved in Italian in real time. You can also compare multiple models, different system prompts, and so, for example, Spanish, and we can see side by side the output of both the models here. Okay. Great. So the playground is really helpful for you can add multiple messages, output schema as well. So instead of having this free form text, you can have a output schema as well. And the playground is really helpful for iterating different prompts, different steps of your applications. Great. So let's go back to tracing project. Previously in the slide deck that I presented, I introduced the online evaluations and offline evaluations. Let's understand how we can actually create online evaluators and use them. So let's go back to our chat LangChain tracing project. And by the way, creating a tracing project is really straightforward. So you can, if you're using LangChain, you just need to specify a few environment variables. While if you're not using LangChain, you just have to specify a few environment variables, but also add this traceable decorator in your method, in your function to log the inputs and outputs. So let's go back to chat LangChain. So before going into evaluators, if you have a chatbot, it's really helpful to have a way to visualize the multi-door conversation that the user is having with the agent. And a way to do so is by visualizing the threads. Threads can be thought of as a list of traces which shares the same thread ID, basically. So we can see here, if we just press in one of these threads, that we're able to see the different turns of a conversation. So turn 1, human AI, and turn 2, human AI. You can see the number of tokens and cost for each turn, and the latency as well. And here you can see there are a few feedback, let's say. And these are feedback auto-generated by online evaluators. So let's go back here in chat LangChain. We have runs, we have threads, and we also have evaluators. If you see here, there are a few evaluators LLMS Judge created, as well as custom code evaluators. And we can see here that there's this helpfulness LLMS Judge evaluator, which has this feedback key called helpfulness. So if we click in, we're able to visualize an overview of this evaluator. So it will output a helpfulness feedback score, which goes from 1 to 10. And we're able to visualize the prompts. So the human prompt, the system prompt, and the human prompt, and with the content that actually is passed into the context. And also on top right, we can see the models used, and also the sampling rate that basically tells you when to run, to automatically run this evaluator. So now you want it to run every 2 traces, so 50% of the traces. And you can actually modify this evaluator. You can specify, for example, this one is should be a system prompt, and also you get to specify which type of information you want to pass into the context of the LLMS judge. And also finally, here you get to decide which the output score, which right now is an helpfulness score with a format, a score format. It can also be categorical and a Boolean, so true or false, from 1 to 10. And we also check this include reasoning that will show the reasoning of the LLM, so why the LLM decided to give that specific score, helpfulness score. So if we go back, we see that there's these logs. We can click in and visualize all the different traces and runs where this evaluator has been invoked. So we already see that here the first trace is a helpfulness score of 8, with also the reasoning of the LLM, why it gave that specific score, and the others are 10, 9. So yeah, we can use the first one as reference, and we can view the run to understand why it gave that specific score. So on the right, we see all the different feedbacks, but we can also click on the feedback view and see the helpfulness score about LangGraph, which is about LangGraph. And if you want, if we think that the output of the agent is actually helpful, more helpful than 8, what we can do is manually modify the score from here. So we could just make a correction, give 9 explanation, and then update it here. Great. Online evaluators are helpful for providing an initial feedback to the all the traces, and that you can actually use to visualize in a dashboard. So if you go in a dashboard, we have some pre-built dashboard for this project where you'll be able to visualize the trace count over time, the latency, the LLM calls, total costs, and so on. And we're also able to visualize the different feedback scores that have been given over time. So, for example, helpfulness score, we see that the average helpfulness score is really high, which means that our agent is our chatbot is performing good, and we can also create alerts. So we can say if for the last 50 minutes the helpfulness score was less than 5, then we send a message to a Slack channel or an email. And same holds for the error rate. If it's more than 50% in the last 50 minutes, we can trigger a webhook, and so we get notified about the degraded performance of our agents. Another thing that online evaluators are really helpful also for creating high quality data set. So previously in the slide deck, I showed you that for offline evaluators, you may want to have a data set which can be manually created, and also created from production data. And let me show you how you can actually create a data set from production data. So let's go back to LangChain, to chat LangChain v3. We see here that we have evaluators, but we also have automations. Automations are a way to trigger an action whenever there is an interrupt or an event. So there are different types of automations. If we go here in new automations, we can see that we can add this trace to a data set. We can trigger a webhook, and we can also add this to an annotation queue. Annotation queue are the place where really experts or subject matter experts can visualize the trace, the real actual output of your application, and provide a score or provide a feedback, a review. And once you have this review and you think that the trace, the sample is high quality, then you could push that sample into a data set, high quality data set. So let me show you how you can do that. So right now we have a few annotation queues where we send, for example, helpful traces annotation queues. So we filter basically the traces by feedback key, helpfulness feedback key with a score more greater or equal than 8. And so all these traces will be sent to these annotation queues. So let me just go into this annotation queue. And from here, we can see that we have the inputs and outputs of our application. And on the right, some feedback and some reviewer notes and some rubrics, some instructions. So you are, since you are the moderator, let's say, you can provide some instructions to human annotators to follow. to generate this feedback. So for example, now annotate the inputs and outputs according to the feedback, be strict and unbiased in your grading. So human operator should evaluate and provide this additional feedback. So for example, here we see that there is I don't really like how the AI responded to me. So I would like to be, instead of I'll do like, let me explain how to use this. I can give a score. And what I can do next is requeue at the end. So if you're not really sure that your feedback is good enough, or you may want to add other people to evaluate again the trace, you may want to recruit at the end, or you can add it to a data set if you think that this is really high quality um, um, trace. And for the sake of time, before the demo, I've actually created this dataset following this workflow. So if you go in this dataset called chat launching golden, so we can go to dataset, look for chat lang chat. So let me look for golden. Yeah, chat launching golden, and we go to examples. We see here that we have a list of inputs from the dataset, and they were partially manually curated, and like the last five or so have been added to the annotation queue, and then we have these reference outputs. So the outputs that we expect our agents to reply with. There are different ways to run experiments or and visualize the quality of your application. One way is through the SDK. So you can use Python, like Langsmith library, and use the evaluate or the asynchronous version of it for where you pass the real output of your application and then the data set and a list of evaluators that you want to run against this your application. And or you can also create run experiments in the playground. So this is the um, uh, um, this is the playground that we've seen previously. The system prompts and the human message, which now contains the input question. And we can run this and basically have an output based on some evaluators. So now here we gotta see the output, which is this one, and also the conciseness score on the right. And we see here that we have a data set specified and some evaluators. So in this case, this conciseness evaluator. All the different experiments, every time you run an evaluator, you create an experiment as well. So if we go back in the this golden dataset, under the experiments section, we can see that we already run a few experiments. This one is the latest one that we can delete because we don't need it. And basically, whenever you run an experiment, you may want to try, as we mentioned in the LLM call, as we mentioned in the slide deck. We may want to modify the model, try a different model, or try a different agent architecture. And here we have done that. So we have tried two different models, so GPT-4.1 and Claude 3.7 Sonnet. And um, and then with a reflection step. And so before providing the answer to the user directly, it will reflect um, on on the answer generated by the agent. And also we tried without the reflection step, so it will provide straight to the user the response. Here it's pretty nice to see the feedback, the output of the scores from these evaluators in a chart view. This allows you to see to visualize the trade-offs, because a model can be more accurate, but also it will take more time to generate the answer itself. Um, so it's always a matter of understanding what you want to prioritize. Um, Another thing that you can do here is you can actually click on the experiment itself, and from here you can visualize the inputs and reference outputs contained in the dataset and the actual output from your application. And also the scores, so the accuracy score, the relevancy score, and the conciseness score. And here you see that the scores are averaged. This is because we will want to run the evaluators multiple times, since we know that LLMs are non-deterministic in nature, and we may want to actually try run it multiple times. So in this case, 3 times, and visualize how the output changes. And the same things goes for the accuracy. So if you click on the accuracy score, we see the different runs, the different evaluators that have been run. And if we press in one of those, we're able to visualize the trace of the LLMS Judge Evaluator itself. So here we see that we have this example from the dataset, the run, and also what we pass to the LLM, basically, with also the scoring criteria and so on. Good. This is basically what you see when you run an experiment against one version of your application. What about how do I actually compare multiple versions of your application? Because right now I'm only seeing the results from one version. To do so, we can click on compare, choose the right model, the right experiment. So for example, let me compare GPT-4.1 without reflection step with Claude 2.7 Sonnet without reflection step. And from here, you see that the visualization changed a little bit, and you're able to visualize the results of the different version of your application side by side. So with the accuracy score, the latency, number of tokens used, and cost as well. And also, since we use the accuracy score as baseline, we see that the second version with Claude 3.7 performs poorly, or worse than the first one, only because the accuracy score is less than the one in the first version. And from here as well, you can expand the trace, visualize not only the evaluator run, but also your full application, and starts from here, from iterating and deciding which step of your application you want to improve. And from here, you also have some charts out of the box that allows you to visualize um, a few data. So for example, the latency, the number of total tokens and prompt tokens, and completion tokens as well. You're able to download the experiments as a CSV, and same goes for the data set. Okay. Let me. So the last thing that I would like to touch upon is the prompts. So there are two ways that you can where you can specify prompts. So instruction for the LLM. One place is defining the prompt directly in your application, so hard coding it, and which might be good. You don't need to fetch it is in your code base, but if you want to try different prompts, what you will have to modify the actual application. You will have to push a a code change in GitHub, for example, GitLab, and then wait for the um, to see the output of your agent, of your application. Another way, instead of hard coding the prompt into your application, is defining the prompts in this prompt hub. Prompt hub is where all the prompts are created and stored into Langsmith. Prompts can be either private or public. So you can also start by creating a public prompt that you want other people to use, or a private one. And prompts can have versions. So for example, let me click on this receipt processing prompt, which is a private prompt. And here we see that this is a structured prompt. So it means that it will not generate, the output will not be free-form text, but it will be an actual structured output. We have the system prompt, we have the human prompt, and with eventually some attachment. And we do have some outputs. So the output schema will be this one. So the output is extract receipt. There will be the employee name, date of receipt, amount, currency, and so on. And this can be pulled into your application by calling this pull prompt method from our Langsmith SDK, and specifying the name of the prompt. You can also include the model itself if you're using if you're using LangChain LLM integrations. So in this case, we are pulling also a chat anthropic library or integration into the app. Once you have built this prompt, you can actually iterate on it. So you can see here there are 17 commits, which means that in this case, Catherine iterated on this prompt, and we can in Europe in the application we can pull different version of the prompt. So not just the latest one, but also specific versions. And also a really powerful thing that is used whenever you want to create a production-ready application is the concept of tags that allows you to define the types of environment that you have. So you may have a development chatbot that you try only locally. You may want to have a staging agent, and also a production one. And you can create tags by creating this. So for example, this is a prod tag, and we can actually pull this prompt by, instead of using this number, this ID, you can just fetch it from the tag itself. So once we have these prompts, how to actually modify it? What you can do is go into playground, like before. We can select a prompt from here, the model, and then whenever we apply um, a new modification, we see here that we can create a new commit for the prompt. And here from the playground, you can either have strings, but you can also have attachment as well. So, for example, you can upload files, you can upload photos, pictures, and so on. Okay. So hopefully, this was a good introduction
No,
to
it
Langsmith.
was it was I learned so much personally. Like it was a lot, and I was really happy about that. Um, so I guess we could go straight into the questions. I'm sure you can see the questions in chat.
Yeah, absolutely. So let me read them out loud. So, is it possible to integrate your specific evaluator metrics into the compare function in the playground on Langsmith, essentially to test how outputs of different models compare with your metrics as reference outputs as a baseline? How would you feel integrate this into the evaluator pipeline to optimize your workflow with the most capable model? So there are a few. You can specify evaluators in the UI, and one way to make it more precise, let's say, is by adding few short examples in the prompt itself, and the prompt can be you can add also custom variables in the prompt, and but custom specific evaluators can be created locally in your app, and then to run offline evaluations basically. And for optimizing the prompts in Langprint, we have a prompt canvas, which basically helps you in optimizing the prompt given some instructions that I haven't covered now. And also we have another feature which is called align evaluations, align LLMs judge, which is basically aligning which is basically aligning the some annotated human feedback with the output from the LLMs judge. And we recently released a YouTube video for that, which I think is it's pretty cool, and I suggest you um, to go and watch it on YouTube, and where it basically shows how to create this align um, evaluator chain, which is this one. So let me share the link in chat. Okay. Okay. So next one will be, is there a limit to the number of projects that can be monitored or traced, or does that depend on the type of plan, free, paid, Langsmith? So it basically depends on the number of traces that you push into to Langsmith. We have a pretty generous free tier on Langsmith that allows you to try it out, and also use it in production with low usage. And also, if you upgrade to the Pro plan, Plus plan, you do have a more traces per month, and also access to LangGraph platform. So if you have built an agent with the LangGraph orchestration framework, you can deploy that into Angular platform and have it up and running, online in production, and people can use it, basically. Okay.
So I don't know if there's anyone that has any other question. If you have any other question, you could put it in the chat.
Okay. Okay. I think it was a really cool session.
Yeah, well, yeah, it's fantastic. Uncle, thank you so much. Thank you from the entire team, the entire community.
Yeah. Thank you for
Um,
this.
yeah, so I'm definitely going to show you this session has been recorded, so I'll definitely send you the YouTube link and also the recordings for your personal usage. And
Yeah.
we'll definitely love to have you again. And this is just the first of many boot camps would because I think one thing that inspires us that we see the impact. Um, people are, people that are in nowhere, they have a lot more clarity.
Mhm.
You've said so much. It doesn't necessarily mean they're going to build AI agents. Maybe it picks up an interest in LangChain, and maybe you might have someone on the call that maybe next 6 months works with, you
Yeah.
know. Yeah, so thank you so much. Thank you from the everyone, and we'll definitely love to have you again. For the people who are on the call, so we're having our next lecture on Thursday, same time. Thank you all, and I think there is a question. I didn't mark right before we go. Okay, okay, yeah, Marco. Someone just mentioned if you share your link. Um,
Okay. Yeah, yeah, I can share my
yeah,
link.
okay. In the mail we'll send. We'll definitely attach it for people who would like to follow Marco on LinkedIn. You should all follow him. Those of you who are going to watch on YouTube, I'm gonna so yeah, please do follow Marco on LinkedIn. Um, yeah,
Yeah, it's and let me just share it here. Okay, this one.
yes,
Okay. Thank you
yeah,
very much, everyone, and
yeah.
have a nice
Take
day.
care.
Bye bye.